Welcome to my channel. In today's video we are going to learn about assignment problem using branch and bound technique. So let us see the branch and bound technique first. For understanding this, we need to know about what is a feasible solution and what is the optimal solution. If you are having the problem space, there are so many solutions available, and the solution that satisfy all the problem constraints are considered as a feasible solution. Example, Hamiltonian circuit problem. So if you are considering this problem, you have to start from the initial node. We have to visit all the cities exactly once, and again we have to reach the original city. So if you are satisfying this constraint, that path is considered as a feasible solution. And optimal solution is, it is a feasible solution, but it will provide the best value for the objective function. Example, among the path generated by using that Hamiltonian circuit problem, we have to choose the shortest Hamiltonian circuit problem. So that is called as the optimal solution. So the branch and bound problem uses the state space tree concept. So here we are starting with the initial node and we are expanding the node with its children, and we need to stop that particular node if any one of these three conditions are right. For example, if that node bound is not better than the value which we have already got, that time we can terminate the node. And the second reason is, if there is no feasible solutions available, that is, if that solution does not satisfy the constraint, we can terminate that node. And the third reason is, if you are having the single point, that node, that objective function is not better than the solution, best solution seen so far. So these three reasons are used for terminating the particular node in the branch and bound technique. So here we are constructing the state space tree. Each and every time we are generating the node and we are checking whether we reach the optimal solution or not. So if you reach the optimal solution, we have to terminate the remaining nodes and provide the solution to the user. Let us see the assignment problem. So here the problem is assigning n people to n jobs so that we can reduce the total cost of that assignment. So for that, here we can consider a cost matrix. So here the person A, B, C and D is available, and there are 4 jobs available, job 1 to 4. So here the cost matrix represents that cost for assigning job 1 to person A is 9. Then assigning job 2 to person A is 2. Then job 3 to person A is 7. Likewise, job 4 to person A is 8. Likewise, we are getting this cost matrix. So from this, we have to choose the optimal solution that should reduce the total assignment. So here, if you are considering that assignment problem using the branch and bound technique, first we have to set up the lower bound, because here the objective function is minimizing the total cost. So we have to set the lower bound. If the problem having the maximization objective function, we have to set the upper bound. So in the backtracking technique, we are generating single children from the node, and we can expand that particular node until we reach the dead end. Here in this branch and bound technique, we are generating all the children of the most promising node. So here we have to place the lower bound. For that calculation, we have to take the lowest value from each and every row. So here the first row lowest value is 2, the second row lowest value is 3, and the third row is 1, and the fourth row is 4. So by adding these 4 values, we are getting 10. So here we can consider this 10 as the lower bound for the root node. So the meaning is, whatever value we are assigning to the person, that total cost should not go below this 10. So this is the lower bound. So we will get a value which should be greater than this 10. So let us start with the state space tree. So here the initial node is numbered as 0, and here we are representing the lower bound. Then we can proceed with the first person. So if you are considering the person A, and here the 4 possibility for the person A, based on that we have to construct this node. So here this first node representing assigning first job to A. So that we have to take the value 9 to person A. Then we have to take the remaining value which is assigned in the lower bound. That is, we have to choose the lowest value from the remaining rows. Likewise, here the second node representing assigning the job 2 to person A. So here the cost is 2. So we are representing it here. Then the remaining rows smallest value 3, 1 and 4. So now we are getting the value 10. Then here the third node is representing about job 3 is assigned to person A. So here the cost is 7. So we are assigning here. Then the second row, already here the third column is assigned, so that we have to choose the next smallest value 4. Then here also, here this is the smallest value, but here the same column value is assigned for the person A, so that we have to choose the next smallest value 5. Then in the fourth person, the smallest value is 4. So we are getting the value 20. And here this is the last option. We are assigning job 4 to person A. So the cost is 8. So for the second row, we are taking 3 as the smallest, and the third one, 1 is smallest, and the fourth one here, this is smallest, but already this column value is recorded, so that we can take the next smallest value, so that we are getting the value 80. So now we have to proceed to the assignment of person B. So among all these 4, here this node 2 is smallest one. So now we have to expand from this node 2. Generated 3 nodes. B is job 1, then B is assigned with the job 3, and B is assigned with the job 4. So now again we have to follow the same thing. The first person's job already 2 is assigned, so we have to keep 2 for all the 3 nodes first. Then we have to take the first job for B. So first job cost for B is 6. So that's 6. Then the remaining rows, smallest value 1 and 4 is recorded here. So the total value is 30. Then if you are assigning third job to person B, means third job to person B is value 3. So that the first person A cost is 2 plus 3 plus the remaining value smallest 5 and 4. Because here if you are taking the value 3, that is job 3 to person B, means this column is also blocked. So then we have to choose the next smallest value here for the third row. So that I am taking 5. Then the fourth row, smallest value is 4. So now the total value is 14. And the node 7 representing assigning job 4 to person B. So the first job already is 2. Then the fourth job to person B is 7. So 7 is recorded. Then the third row, smallest value 1. So it is recorded. Then the fourth row, here already this job 4 is blocked for person B, so that we can take the next smallest one. Okay, so next smallest, here also the 6, it is blocked for person A, so that we are taking 7 here. So now after adding this, we can get the value 17. So now 2 persons are allotted with the job. So now we have to take the smallest one. So here we can choose this node 5 is smallest one, so that we can expand the state space tree from this node. So now among these 3 nodes, this 13 is smallest. So now we can expand from this node. And now we are taking the third person C, and if you are assigning the third job, means there is only one possibility for person D, that is the fourth job. Likewise, the other possibility for the person C is fourth job. So there is only one choice for person D, so that these 2 choices can be generated in the single node. Now we can assign the cost. So already the person A and B cost is recorded. So now we can take the third job for C, the cost is 1. Then fourth job for D, the cost is 4. So the value is 13. Likewise, here also we are calculating By assigning fourth job to C and assigning third job to D, we are getting the value 25. So while comparing these two values, this 13 is smallest one. So now we can consider this is our solution. So now we can terminate the remaining nodes by comparing the value. So here the 25, 14, 17, 20 and 18 all are greater than our solution. So our solution, this 13 is the optimal solution, so that we can terminate the remaining node. So this is the final assignment for this assignment problem. So hope you have understand about the assignment problem using branch and bound technique. Thanks for watching.